Material 3. Take down the heading as determination of relative density of a liquid, using U-tube. Determination of relative density of a liquid using U-tube. Practical number 3. Of a liquid using U-tube. Right. Okay, you know U-tubes, right? What's the U-tube? Do you know? Huh? What's the U-tube? Do you know? Okay. No questions? Right. Okay, look at here. Determination of relative density using a U-tube. First, the theory part is this. Now, this is an experiment which comes in hydrostatics. The theory part comes in hydrostatics. Right? Hydrostatics. U-tubes. See, this is a theory. Look at the board. Don't write, just look at the board. This is a U-tube. Say two different liquids are put onto the U-tube here. Two different liquids are put onto the U-tube here. This is one of the liquids. Right? And this is the other liquid here. Right? The point where, or the interface where the two liquids meet each other, this point is called the interface. That is called interface. Right? The level where two liquids meet each other is the interface. That is called the interface. Right? And this is open to surroundings from top. So it has P naught. Let's assume P naught as atmospheric pressure. If there is any surface which is open to atmosphere, it has atmospheric pressure. If there's any surface. Now, if we take our body, how many points are open to atmosphere? 10? Sorry? No. What are 3 points? How many points of our body are open to atmosphere? Yeah, what are 3 points namely? Points, I'm asking about points. How many points? Infinite number of points are there. Right? So there are infinite number of points which are open to atmosphere. Each and every point on this body feels atmospheric pressure. Right? That's why we feel nothing. Because from everywhere, that pressure is same. Otherwise, if the pressure is higher in one side, you will feel a pain there. Right? Right? Now, even though atmospheric pressure is a very high pressure, as a value, atmospheric pressure is this much of pascals. It's a high value. Right? Even though it's a very high value, we feel nothing because each and every point of our body is on the atmosphere. Right? Then from all sides, that same pressure acts. Resultant cancels. That's the reason. මේ වගේ ප්‍රෙෂර් එකක් එක තැනකට වගේ ඇප්ලයි කරොත් මේවා කැඩිලා යනවා. මේ ලොකු ප්‍රෙෂර් එකක් මේ. ලොකු ප්‍රෙෂර් එකක් මේ තියෙන්නේ. Right? Okay, now these two limbs are open to atmosphere. So it has atmospheric pressure there. Atmospheric pressure. Right? Now, let's say the height from here to here is H1 and density of this liquid is ρ1 and height of this liquid from here to interface is H2 and density of this liquid is ρ2. Right? So we know pressure difference due to a liquid column can be written as H rho g. Pressure difference due to a liquid column can be written as H rho g. Right? In hydrostatics, we know pressures at same points, same levels are equal. Let's say A and B. Now from hydrostatics, PA equals PB. Pressure at a same point of a liquid, of the same liquid, is equal. Pressure at the same level of a same liquid, same horizontal level of a same liquid is equal. Right? So therefore, PA equals PB. Pressure at A can be written as, now starting from here we have atmospheric pressure plus going down, when moving down plus H rho g, moving upwards minus H rho g, moving down in plus H1 rho 1 g, equals PB from the other side, P naught plus H2 rho 2 g. Right? Now if you simplify this, P naught to P naught cancels, G to G cancels, H1 rho 1 equals H2 rho 2. So this is the theory which is relevant to this point, relevant to this experiment. Right? Using this theory, we are going to do this thing. We are going to determine a relative density. Right? Next, we'll see what a relative density is. Right? We have discussed. We'll see what a relative density is. So before that, this is the first theory part we need to understand. If you have an interface is at the same horizontal level, pressures at the interface are equal if that's the same liquid. May same liquid at A also, this black liquid is in contact, at B also, the same liquid. Otherwise, if there are two different liquids, it's not the case. Right? It should be the same point. That's why we consider the interface. We can't consider somewhere here, because then it's not the same liquid. Right? Therefore, it's a must to consider an interface. Right? Okay, take it down. Theory. Sorry, before taking down, write this point. Under theory, write this point in red. Pressures at same horizontal level, pressures at same horizontal level, pressures at same horizontal level of a same liquid, same horizontal level of a same liquid are equal. What is P naught? P naught can atmospheric pressure. P naught atmospheric pressure. Right, now take this down. Take this down. The theory behind this experiment. The theory related to the experiment. Take it down. There is one more thing to add here. Tell me, what is the relative density? What is the relative density? What is relative density? What is relative density that you learn in hydrostatics? I need a quick response. Relative density, relative. What is relative density? Yeah. Density relative to atmosphere, no. Okay. Yeah, I got correct answers from few of them. Yeah, correct. Relative density is the ratio between density of an object to density of water. Relative density means density of any substance, actually. Object can a substance. Density of substance over density of water. This ratio is called relative density. Density of water. This ratio is called relative density. Right? Relative density is a ratio. Relative density is a ratio. Relative density is a ratio. Right? This is the ratio. That is called relative density. Right? What's the value of relative density of water? What is the value of relative density of water? Now you have the equation. 1. Yeah, it's 1. Relative density of water is 1 because relative density is density of a substance over density of water. If I need relative density of water, which means density of water over density of water, 1. Right? Yeah, that's the idea. That's the idea. Okay, good. So this is the theory part involves here. Take it down. Take it down. This is the theory part involves here. Okay. Questions. So what's that formula you have written at the top inside? Delta V equals H rho G. Pressure difference of a liquid column is H rho G. Are you from 27 batch? Are you from 27? Yes, that's why. Right? Otherwise, if you are from 26, right? If you are from 26, now you should be in waves, right? මොන ක්ලාස් එකට ගියත් දැන් waves වල තමයි ඉන්න ඕනේ. ඒතර මේවා ඔක්කොම complete කරපු parts. That's why I asked. If you are 27, that is totally fine. Right? 26 කවුරු හරි ඉන්නවා නම් ඒ equation එක දන්නේ නැති. ඒක හරියන්නේ නැහැ. Because that is something covered in hydrostatics. Right? Okay. Okay, let's move on. Okay, this is the respective theory part. Okay. Look at here. This is the respective theory part. Okay, now look at here. Okay, first thing is, now we have to have a YouTube, right? We have to have a YouTube. Okay, now this is the YouTube. Look at the board, don't write. Don't write, just look at the board. This is the YouTube, right? And if we are finding a relative density, or if we determine a density of a liquid using a YouTube, we can't use two miscible liquids, right? We have to use two immiscible liquids, because if these two liquids are mixing each other, you don't see an interface, right? So it's a must to use two immiscible liquids. That's very important. Huh? Only for two immiscible liquids. Huh? Only for two immiscible. Only for two immiscible liquids. This is only for two immiscible liquids, right? Like water and coconut oil. Water and coconut oil, they are not mixing, right? Now you can't use water with pure water with salt water. They mix each other, right? Water with what we call what the petrol නෙමෙයි petrol වගේ දාගත්තේ ඒකත් හරි kerosene, right? Kerosene use කරන පුළුවන්, that is not mixing with water, right? If there is not mixing only, you can use it in a YouTube. Otherwise no point of putting or including two liquids into a YouTube if they are mixing each other. You don't see an interface, right? Listen, few important facts. Okay, now about the materials. Now one thing is we need a YouTube. First thing you need a YouTube. First thing you need a YouTube, right? And we need two immiscible liquids. And when we insert liquids into YouTube, we have to make sure that the liquid with higher density is inserted first. There's a pure logic, a solid logic behind that. The logic is this, listen. The logic is this. If you include the density with lesser liquid first, once the density with higher liquid is put onto the YouTube, the liquid with lesser density spreads to both limbs of the YouTube. Got it? So therefore, it's a wrong practice. Experiment. So therefore, when questions are coming, that's a very frequent question that is asked from you always. Right? You have to know it. Always the liquid with higher density should be put first. Otherwise, if you do the other way, the liquid with lesser density spreads to both limbs. Right? Now, it should be put to the higher density. Yeah? Higher density. Liquid with the higher density should be put to the YouTube first. Look at here. Okay, now this is the liquid with higher density. And then only you can put the liquid with lesser density. And we have to make sure that, listen, you have to make sure that this interface is not in the curved part of the YouTube, right? Because then that interface is not going to be horizontal. If that is moved to the curved part. So therefore, you have to keep your interface at the vertical limbs. Then YouTube එකේ vertical දෙකයි මෙතන මේ curve part එකේ තියෙන්නේ. Curve part එකට interface එක ගන්න බෑ. ගත්තොත් වැරදි. Right? So therefore, you have to make it sure we are the one and you are the one who are doing the experiment, right? So interface should be on the vertical limb. Don't take it to the we don't take it to the curved surface, because then the interface is going to be inclined. That is not horizontal, right? Then the experiment will be erroneous. There will be errors in the experiment. Okay, listen. Now, other than this, now this is the interface. This is the interface. Now, other than this, we have to have two half-meter rulers. Two half-meter rulers. What is that for? That is to measure these heights. Right? We'll be taking 2 half-meter rulers and we are fixing rulers close to the limb like this. We are fixing the ruler close to the limb like this. Right? And this side also, look at the board. This side also, we have to fix the ruler close to the limb. Now, this is the meter ruler. This is a meter ruler. A normal meter ruler, a half-meter ruler. So, from that, we can read the readings. Two meter rulers like this. Right? Okay. Now the purpose of fixing meter rulers is to measure heights. Otherwise, we can't measure these heights. We need H1 and H2. We need H1 and H2. H1 and H2. To measure it, we are using a meter ruler. Then just behind the limb, we have a meter ruler. Then easily, just by looking at the meter ruler, we can get the reading. Right? Reading here minus the reading here will be the height of the column. Simple as that. Right? Now, let's assume the reading here is reading here is x. මම ටියුට් එකේ දීලා තියෙන ලේබලින් එකම යූස් කරන්නම්කෝ. එතකොට ලේසියිනේ. See, reading here is x, and let's say reading of the meter ruler here is z, and reading of the meter ruler here is y. This is also same z, right? Then x minus z will be x minus z will be this height. Let's label it as listen, I didn't explain you about the liquids we are using usually. Most frequent liquids, frequent in this is popular liquids we have in labs are, most popular one is, no doubt, that is water. Most popular one is water, right? That's the easiest one to find. Most availability is with water, right? So therefore one side is water. Liquid with the higher density is water. We usually use water. In lab එකේ කරද්දී use කරන liquids water. And for the other side we use coconut oil. Usually coconut oil, right? Coconut oil නැත්තම් kerosene or something, right? Usually coconut oil. Even though coconut oil is a little bit expensive these days, we are still using coconut oil, right? So this side, this is coconut oil. Experiment and use මුකුත් වෙන්නේ නැහැ now. If you need to cook again, you can take it out and cook, right? මුකුත් වෙන්නේ නැහැ ඉතින් experiment එකට විතරයි use කරන්නේ to determine density of coconut oil, right? Okay. Density of, all right. Okay, then let's label this as, don't write, just look at the board. Let's label this height as H oil, HO, and this height as HW, height of water, right? H of oil and H of water, right? Okay, now there's nothing beyond this thing. If we have an interface, we know pressures at the same level of the interface will be equal. Now we are going to equate pressures. And if I need relative density can be made in the equation, can be built up in the equation, and we are going to do something to find it out, right? Okay, let's see what we can do. Before that, next heading, did we write materials and apparatus? No. Okay, next heading, materials and apparatus. Next heading, materials and apparatus. Next heading, materials and apparatus. Interface means the separation of two liquids. Yes. Meeting surface of two liquids. Could you please explain again? I had network issues. Which part do you mean? So don't worry, I'll explain again anyway. Right, materials and apparatus, and under that Subheading materials. Under that, subheading materials. Okay, write down one by one. A YouTube. A YouTube. Here. A YouTube. A YouTube. A YouTube. Second one. 2 half-meter rulers. 2 half-meter rulers. 2 half-meter rulers. Then these two. Coconut oil. Coconut oil. Coconut oil. Water. Water. And a set square. I'll explain why we are using a set square. Right? So in the list, write down set square. Set square. Okay, then apparatus. Next heading, apparatus. Next heading, apparatus. Apparatus. Take this down. Take this down. Take down apparatus. What's under PO in formula? That is not PO, that is rho naught. Rho naught. Hope you know rho. Rho, that is rho, density. Rho naught or rho water. Apparatus and setup. Simply, listen again. Simply, take a YouTube and fill the liquid with higher density first, and then fill the liquid with lesser density second, and make sure your interface is not in the curved part of the tube, and fix 2 meter rulers close to 2 limbs of the YouTube, right? And then we didn't do anything. We are going to measure these heights. That we will discuss in the method. Finished? Okay. Then method. Next heading, method. Okay. Write down with me. Since pressures at same horizontal level. Since pressures at same horizontal level, you can write along with me, are equal. Since pressures at same horizontal level are equal. And label P naught here as well. P naught. And here also P naught. And I'll introduce P naught here. P naught is atmospheric pressure. Atmospheric pressure. Right? Now, let's say these points are A and B. This is point A. And let's say this is point B. Now, what we can say is pressure at A equals pressure at B. Pressure at A equals pressure at B. Pressure at A can be written as P naught plus HO. Let's assume the density as rho O, right? Let's assume this density as rho O, and let's assume this density as rho W. Rho OG equals P naught plus HW rho WG. P naught to P naught cancels, G to G cancels. So what comes is H naught rho naught equals HW rho W. Right. I'll erase this part now. Okay. See, Now, what we need is relative density, right? Relative density is the ratio between density of substance to density of water. No? Then rho W is my density of water. I have to create the term rho O over rho W. To create rho W, I'm going to divide this by rho W. Right? We are going to divide this by rho W. Now, from the equation, I'm taking the equation again to here. Look at the board. Now, the equation we have got is H rho O equals HW rho W. Right? To create the term, we can write this. We can write this like HO rho O over rho W equals HW. Right? Which means HW equals rho O over rho W times HO. Right? Okay, now here I have created the term relative density. Rho over rho W, that is relative density. That is what we discussed in the theory. Right? Okay, then when we are going to plot the graph, see, now we are going to change, listen, we are going to change the height of the liquid column of the lesser density. Right? Now, if you do the other way, there is no point of doing that, because now if I add more water, what happens is interface goes up, but the liquid level above the interface remains same. Right? If we didn't add coconut oil, so therefore always coconut oil will be added. Liquid with lesser density is added. Right? So when it is added, both heights are changing. Right? So therefore HO changes. So by manually we change HO, which means that is the independent variable x. Right? So therefore HO is the independent variable x. Right? Whatever it is as a product with x is the gradient here. And y is changing accordingly with x. So y is y. Again, an equation comes as y equals mx. An equation comes as y equals mx. Right. Now, if we plot the graph, see, now if we plot the graph between instead of y-axis we have HW and here HO, and that will be in the shape of y equals mx, like this. And now if we check the gradient, see, gradient, simple limb of the graph is rho O over rho W. Right? Now, what we can do is very simple as this. Look at here, gradient equals rho O over rho W. Right? And rho O rho W is actual relative density. Right? Which means after plotting the graph, when we determine the gradient of graph, gradient equals to relative density. Our target was relative density. Determination of relative density of a liquid using YouTube. Now, since we have the graph, we have a graph now, which means gradient of that graph is known. Can be determined. Points එකක් හොයාගත්තා y over x එකක් දැම්මම gradient එක එනවා. If gradient is known, which means relative density is known. Now from the graph, gradient is known. If that is known, when the gradient is known, relative density is known. Right? That's the end of the experiment. Very simple. Very simple. Right. Now, yeah, under method, starting from here, take it down all the way up to this point. Take it down all the way up to this point, and then we'll be writing the note again after this point. Finished? Slow down. Slow down කරන්න පුළුවන්. Slow down කරලා 2:30 කොහොමද ඉවර කරන්නේ? Now my plan is to finish all by 2:30. Right? Now if you can stay until like 334. I can slow down and do, right? And this is not the speed. Make a speed can. Paper class එකේ මේ බලන්න speed එක. මේ speed නෙමෙයි, this is slow. In my case, this is slow. Right? This is not the speed. Speed case එක මීට වඩා ගොඩක් speed. Right? This is average actually. මේ slow නෙමෙයි, this is average. This is average. Okay, finished? Okay, below this, write down with an asterisk mark, write down. Since gradient can be determined using graph, 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 relative density of liquid, relative density of liquid, relative density of liquid can be found. Relative density of liquid can be found. Relative density of liquid can be found. Right? Okay. That's it for the method. As the next heading, write down remarks / important points. Important points. Next heading, remarks / important points. Remarks / important points. Okay, first point, first bullet point, that is about this I explained. Always the higher density will be put first. First point. Before that, about the immiscible thing I will mention. First point, can be used only for two immiscible liquids. Can be used only for, can be used only for, can be used only for two immiscible liquids. Can be used only for two immiscible liquids. Can be used only for two immiscible liquids. Second point, the liquid with, the liquid with higher density, the liquid with higher density, the liquid with higher density should be put into YouTube first. 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 Within brackets, otherwise, liquid with lesser density, otherwise liquid with lesser density goes to both limbs, otherwise liquid with lesser density goes to both limbs. Close the bracket. Next point. Readings are taken by adding. Readings are taken by adding. Readings are taken by adding the liquid with lesser density. By adding the liquid with lesser density. By adding the liquid with lesser density. Within brackets, otherwise, there won't be a change in liquid column heights. Otherwise, there won't be a change in liquid column heights. Next point. Interface should not be at the curved part of YouTube. Interface should not be at. Interface should not be at. Limbs. Limbs කියන එක අහලා නැද්ද? Limbs. Limb. Right? What did I say? Interface should not be at the curved part. Should not be at the curved part of YouTube. Should not be at the curved part of YouTube. Next point. Next point. A set square. A set square. A set square. A set square can be used to. A set square can be used to. A set square can be used to increase accuracy of readings. Increase accuracy of readings. X, Y, and Z. To increase accuracy of readings X, Y, and Z. Okay, listen, if the set square is available, what we do is we can place the set square like this here. And if we keep that set square exactly in line to the water level, we can easily read what this division is without looking at the liquid inside always. Because in the liquid, we will see it through refraction that is inside the glass tube. Right? මෙහෙම set square එක තියලා බලුවොත් තව පොඩ්ඩක් හොඳට reading එක ගන්න පුළුවන්. set square එකේ reading එක නෙමෙයි reading එකේ meter ruler එකේ. අරක indicator එකක් විදිහට තියාගන්න. Right? මෙහෙම set square එකක් තියලා මෙහෙම කරලා reading එක බලනවා. Right? That increases the accuracy of readings. Right? That's why I mentioned the list. Mention set square in the list. Right? Okay. That's it. So that's the end of practical 3. Right? That's the end of practical 3. Any questions? Any questions? What about you? All clear? Online students? Zoom, YouTube? Someone can answer for the questions regarding the note now, because I'm not looking at the note and giving you the note. I'm just keeping this in mind, thinking about this and giving the note instantly, right? So therefore, I can't recall that in exact words. Okay, clear. No questions? Feeling hungry? No. Feeling hungry? No. Yes. What about online students? You don't feel hungry because you had something in the class. Yeah, what about you? Online? What about the ones on YouTube? XYZ are readings. Yeah, readings. XYZ can readings. Now, if you need H note, maybe HO, okay? HO is X minus Z, and HW is Y minus Z. They are readings, right? I have put the same thing in the tube as well.